Now, all of that was supervised by Houston as well as Saint-Hubert in Canada. Little is known about the backroom of SPDM in Canada because it's proprietary information. So what I can tell is in Houston, preparation of SPDM operation is highly complex because the arm is complex. It has two arms and a body, and it can go in very small places. And this requires a lot of training and a lot of preparation. For instance, these people that are really flying the arm in the control room and take control of SPDM, for instance, to grab the camera we have just seen and exchange it, it takes 4 years of education. So once you arrive as a flight controller, it will take you up to 4 years to be in the front room and to be able to send the commands to the arm so that it can execute all that. It's a sequential, of course, operation. So it's a lot of work also on the ground to do all that. Then a few words about GEM-RMS. GEM-RMS characteristics. Little is known about GEM-RMS because the Japanese do not really disclose much information about that. The cost itself it looks pretty big on the chart, but it's actually part of the main contribution of Japan to the main laboratory, because the arm is attached to the laboratory, it doesn't go anywhere comparing to SSRMS. GEM-RMS stays attached to the module and manipulates payload on the platform. It's already like SPDM, so more than 8 years, 7-8 years in service, and it's regularly operated by the ground. And the GEM-RMS, it's only flown by ground. The crew doesn't really touch it. As we will see in a few slides, the crew is trained to fly it in case of contingency, in case something is really out of the normality there. But in the end, the ground does everything. So usually they exchange payloads on the external platform of the Japanese module, or they take things coming out of the HTV, as we have seen some slides ago, and install it on the platform to run a new payload or exchange equipment. So the speed are very similar to SSRMS. It's practically a lower scale SSRMS attached to the Japanese module. It's handled by ground, as I said. We don't know much. All right, so ISS Robotics training, it's something interesting because it's when you are selected as an astronaut, there are few skills that you need to learn. I'm talking about skills. I'm not talking about all the things that astronauts will have to know, but a crew has to know practically from skills EVA, rendezvous and docking, robotics, and also all the rendezvous, the re-entry after the flight. So these 4 main skills that they need to learn, and it has to become a second nature. One of the main of the skills that an astronaut should know is robotic. And that's why the training is pretty heavy on them. And I myself, part of this training group where we prepare astronauts for flight by teaching them robotics. And the total hours that the crew will spend in learning robotics is about 300 hours. It's a lot of hours. So if you count, it's something like 8 weeks full-time. And of course, we don't do in 8 weeks full-time. So what we do is we slice it into a different period during their curriculum. So first of all, they start with a generic robotic training, and for European crew, what we have is 30 hours of training, and this training is done in Cologne at the European Astronaut Center where I work. So it's about 30 hours. Then once the crew have known all the generic parts of the training on robotics, they go to Canada for a compact 2 weeks of training, where they learn more about the system, the mechanical interface, how the arm is built, and the main operations of the arm. The big part actually of the training is happening in Houston, robotic specialist skills, so spec skills in the barbarian language, where the crew will spend more than 100 hours, so 150 to 200, but now it has been reduced, and a few hours in Japan, as I mentioned before, where actually the crew just learn few malfunctions on the GEM-RMS. But most of that is the crew will repeat and repeat and repeat during this period. Track and capture, spacewalk support, as well as some other tasks, but mostly is like track and capture for visiting vehicles and support to spacewalks. And once they have done all these things and they have adapted, at the end the training is really tuned to the mission. So when they know that, oh, I will install a new antenna on, let's say, the truss, they will train to install this on the truss with the ground. Then they have few hours of onboard training, few hours where they train again, usually track and capture for visiting vehicles. So for instance, when Dragon arrives, a couple of days before, what we have is the crew is practice on the simulator, the approach and grabbing Dragon with different malfunctions, so you can imagine where the vehicle drifts faster or slower. All right, and this is for crew. As I mentioned before, to become a flight controller, it takes 3 to 4 years full time with hard work to be able to control the arm from the ground. And of course, when you send commands to the arm in the flight control room, you are not alone. You have 2 or 3 persons in the back room pre-sending the commands for you to approve, and then a big army of people preparing all that for months and months and months before this is happening. So flight controller is it's a long way to be able to actually command the arm on the station. And why it's like that? Because the arm is a moving thing that can collide with the station, and you don't want the arm suddenly to have a collision on board, and because you didn't watch carefully all your clearances, and then you have a depressurization. So the content on the training itself, I will not detail it, of course, too much, but here you see, for instance, an example of basic training. So during basic training, what's happening on the ground, for instance, in Europe, we train the crew in several things. So we train the crew a hand controllers technique, so how well you should fly the arm, how you should handle this translation and rotation in a nice way. And of course, we teach the crew how to handle the system information on the left screen, and on the right screen, we teach the crew how to look carefully at all these videos and the camera's information, the central one being the main, and you have a scan pattern where you look right and left on your screens, as well as the telemetry. We use also some teaching aid. Teaching aid could be a small model of the arm to better understand the situation. Hey, you are flying the arm like this, but this is the configuration of the arm. And also a big part of this training is to make them understand that to fly the arm, you need to jungle in your mind with different coordinate system. And this is not easy, because you need to have a 3D map of switching from one reference system to another one when I fly the arm. So I fly the arm in that direction, but in the space station direction it's that way. And if I have a crew member at the end of the arm, for the crew member it means that, but for me it means that, and for the station it means something else. And I have to convert this into inputs in my joysticks. And the inputs I have to give have to match exactly what the crew member at the end of the arm wants to have. If you fail to understand and to make all this mental map between what the crew member wants and how you are able to command the arm, that's a problem. And therefore, we have so many hours of training. Once the ground training and the basic training is finished, we continue in Houston. And here you see Andreas Morgensen, for instance, in the foreground with his instructor from Johnson Space Center. On the simulator, he's practicing the track and capture of HTV. As I said, we have few hours of training in Japan. Here you see 2 European crew members during their training. In Japan, it's already more than 10 years ago, and they are practicing small items on GEM-RMS. Once you are in space, as I said, you have few hours of onboard training. This is the last part of your training, and this is the first time in your life, if you are the first time flyer, that you see the real arm. So far, all these hundreds of hours of training you have done, you have never seen the arm. You are flying on a simulator, you never see it. And so for the first time, the onboard training includes a real maneuver with the arm. So here you see Samantha Cristoforetti for the first time in the cupola, practicing on the hand controllers to move the arm a little bit, so that you have a better feeling of how is the real arm moving comparing to what you have trained in an extensive manner on the ground on simulator. So that's also part of this onboard training, is you feel the arm. It's like the first time you have a brand new car, and you will not drive normally at the beginning. You will just give it a try to see how it feels. The interface the crew has, and we will see also the interface of the arm have available, it's an important aspect. So how are the interface of the arm? So the arm, here it's this picture that you have, the SSRMS Lee, so latching and effector. This picture has been taken last week. So I just took this picture from the onboard database and I included it into this presentation to show you that, and this is probably one of the best pictures I've ever seen, and it took more than 15 years to have such a good picture taken. And you see how the end effector, so what's the hand of the end effector? As I said, the arm is symmetrical, so the same is on the other side where the arm is attached. So again, this can become the hand or the shoulder, it depends what you do. So here the hand, you have a huge cylinder in the middle that is able to grab the pin, as Mike explained in the video, and all around that, the four things you see are connectors to make the electrical connection, as well as hooks to hook up the arm to the grapple fixture. You have just grapple. You have different interface. Some of the grapple fixture we can capture are only mechanical. There is no electrical connection, no videos. And some others are electrical and videos and mechanical, but all of them are mechanical. This is pretty big. So here what I'm talking about, the diameter of this end effector is something like this. So it's pretty big, and it can manipulate only big payloads. You will never, if we take the example of a small payload like this, you will not mount an interface like this to be manipulated by the SSRMS. So on this picture, you see, for instance, on the right-hand side, a typical grapple fixture, only mechanical, where the arm is able to grab, and on the top you see the target, which is used by the camera to align before you grab. And on the left side of this picture, you see that once you are well aligned and you want to grapple that payload, you have a series of snares that will swirl around the pin to grab that pin and put it right in the center of the arm. And then once you have taken the pin with this snare, so the cable, you will retract the inside of the arm, and then you will make the mechanical connections and the electrical connections. So that's the interface with the SSRMS, which are, as I said, mechanical. They are always mechanical, but they can also be electrical. All the modules on the station that have been assembled, like all the years of the station assembly, have this kind of grapple fixture that you see. Then for the SPDM, so the SSRMS, which is way smaller, so what you see on the left-hand side is an interface like this. So this is one of the hand of SPDM, and it has two arms. It can grapple smaller things. So you see there's a gripper in the middle. It can really slide and then grapple like a diamond shape grapple. And you see on the top screen, on the right-hand side, you have like two of the possible diamond shape fixture you can get. And if your payload or the object you want to manipulate is a little bit different, or is too small, or in a very strange area, you can add a tool. So the SPDM is able, so you have the body of SPDM and two arms, and the SPDM is able to grab a tool like you will grab a screwdriver to open and close something, or you can screw a screw or unscrew, but you need a screwdriver. And SPDM is the same with this gripper. You can grab an intermediate tool to be able to manipulate the payload. And that's the three possible options you have with SPDM, is you grab one of the three tools to access some of the other interface. So these are the tools.